Hey everyone, this is Ray, and I was assigned section 4.7, number 4, and it says a piece of wire 20 meters long is cut into two pieces. One piece is bent into a square, so we have a square. The square has all sides are equal, and the other is bent into an equilateral triangle. So it's 20 meters. And these sides are all equal for this one as well. How should the wire be cut to maximize the area enclosed by the square and triangle? We have a hint here, it's area. And also it could be, area is the perimeter around the square, and then the perimeter around the triangle. And so each side here, we'll call it X. Side length is X, 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 and they're all the same. And here is Y, Y, and Y. And the constriction for this is this plus this has to equal 20 meters to maximize the total area. So you have 4x plus 3y has to equal to 20 meters. Okay, so knowing that information, now we need to find the area for this one. The area for a square, the formula, is going to be just x squared, this sides, length times width. And then we have here the area of a triangle is 1/2 base times height. We know what the base is. The base is y. So we have 1/2 y times height. What is height? If you look at this triangle has 180 degrees. Equilateral triangle. Yeah, every triangle has 180 degrees. And so knowing they're all equal lengths, you know each one is 60 degrees. So here's 60, here's 60, and here's 60. The height of a triangle can be found if you just turn this into a right triangle, and this will be the height. So if I want to find the height of the triangle, I would say, and we'll call each side y. This would be y. This is 60. This will become 30, and this will become 90. And this will be 1/2 y, or the half of y. We know from, and this is h. We can either take use the Pythagorean theorem to find what h is, or we could look at the 30-60 triangle, what do you call it? I'm trying to remember, but like this would be like a 30-60 triangle. 60, 30, for example, where it would be the side opposite of the 30, the angle 30, the standard, sorry, yeah, there we go. The standard right triangle, you have the side opposite of the 30-degree angle is, let me get a lifeline here. It will be 1, 2, and this will be √3. That's the standard triangle right here. The side adjacent would be √3. Just want to confirm this. Yes, I believe that's correct, yeah. I want to say the side adjacent to the 30-degree angle, is that correct? So this could be y, 2y, and y root 3. You know what? I feel like 2y, that should be correct. The side adjacent to the 30-degree angle should be that. Yeah. That looks correct to me. Yes. Okay. So in this triangle, which matches this triangle, we have 60 degrees here, the 30 degrees here. So I know that my height is going to be y times root 3. And y in this case is, this is y. If you can see, this is the y. This is the 2y, because y over 2 times 2 gives you y, and that's the y right there. So this has to be the y times root 3, excuse me. Y over 2, this is y, times root 3, which gives you that h is equal to root 3 over 2 times y. Okay. So just to go over this again, the side opposite of the 30-degree angle should be 1, or y. The side adjacent to it should be root 3 for a standard 60, 30, 90-degree triangle. A 30, 60, yeah. And then this would be the hypotenuse, which is twice the y, or 1, so yeah. So if we're looking at the same one, we'd say the side opposite of it will be, we know from this triangle, the half of this is y over 2. Just want to like clarify where I got those numbers. Because this is y, this is, and it's cut in half, so it's half of that. And this is equal to pretty much like 1. This is twice of it, so that must be 2. And then this is root 3. And root 3 is usually y times root 3. And then y in this case is this. If it was 1, it would have been just 1 times root 3. Like this one, 1 times. Okay, so hopefully you guys see where I got that height from now. So I have 1/2 times the base, which is all of this, going back to the beginning of the triangle, is y, times the height, which we got to be y over 2 times root 3. So we have root 3 over 2 times y. Okay, and then if I just write it all across, it would be the area of a triangle is equal to root 3 over 4 times y squared, or the side squared, which is, if you look this up, this is the area of a equilateral triangle, but this is how we got it, by using what we usually know, which is the 1/2 base times height. So now you have the area of this, and then the area of a square. So the total area is equal to the area of the triangle plus the area of the square, which we have x squared. Excuse me. Yeah, x squared plus root 3 over 4 times y squared. Now we can use this to find the let me see if I have all this correct. Yes, we have that. Oh, and then since we have x squared here and y squared, there's 2 different variables. We want it to be all in terms of y squared. So we go look at our original problem, which had 4x plus 3y is equal to 20 meters. And so I would multiply, or take this over here, subtract. And so I have 20 minus 3y is equal to 4x divided by 4 divided by 4. So now we have x is equal to this. So we can plug it into this area total. In terms of y, everything would be 20 minus 3y over 4 plus 3 over 4 times y squared. And then we just take the squared. This is x, because this is x right here, is equal to x. And then plugging it into that, it'll be area formula will be this number, x squared. So now we could take the derivative of the total. And so this is, let's call this x, so it'll be 2 times 20 minus 3y over 4. And then if we do the inner, all of these are just variable, or numbers without variables. We only have the 3y, so we will multiply it by just -3. Plus the root 3 over 4 times y squared. And then if I want to take the did I do this right? Yes, I think I did do this right. Yeah. Now I have to take the derivative of this. So I have the derivative of that one. I'll just write it out really quickly. We have -6 times 20 minus 3y over 4. You know what? The way I had originally did it was, let me see. So far I have up until here, I'm comfortable with this. It's taking the derivative of that I'm not happy about right now. So let's fix that. A total would be 20 minus 3y over 4 squared plus root 3 over 4 times y squared. So the first thing I did in class with the help of RJ, shout out to RJ, was just take this 1/4 out so I can comfortably do the derivative. So when I do the derivative of just this part, the first part, I did 1/4 20 minus 3y, because we could do that. We can take out a fraction. So I took out the fraction, and then I do this. Now I took the derivative of that, and I'll have a total is equal to 2 times this, which is 1/2, pretty much. It'll be 2 over 4 times 20 minus 3y, and then the inner function now would be just times 3y times -3. Yes, okay. If you can always take out the fraction, just do that to make it easier in terms of finding the derivative. And then here I have y squared, which would be the derivative of that is plus root 3 over 4 times 2 times y. Yeah, so this is hanging around it. So usually when I'm taking the derivative of this kind of problem, I would do, let's say like this is 2y squared. I would just multiply this number by 2, which is what I'm doing here. This times 2. Let me rewrite this. I would say 2 times root 3 over 4 times the derivative, which is 2 minus 1. 2 minus 1, which is equal times y. There we go. And then I'll put them all. Okay, and so I will need to use the next page. So now I have is equal to I have yeah, okay. I have the 2 times the 20, oops, 1/2. Just rewriting this problem. But I noticed that I also like distributed that, so I'll do this in this side. So, but just to stay consistent, I'll just rewrite it. It's minus 3y times negative 3 plus 2 root 3 over 4 times y. Okay, and then just rewrite this again. Okay. Now we set this equal to 0. So 0 is equal to negative 3 over 2 times 20 minus 3y plus 2 root 3 over 4 times y. And then we just distribute that, so we have negative 3 times 20 divided by 2, 60, so that's 30. We have 30 minus negative 3 times negative 3y. I have positive 9 y over 2. Yeah. And then this is distributed just fine. Plus 2, 3 over 4 times y is equal to 0. And then over here you could see that I can also simplify this a little bit more. So 2 goes into 4 twice. Shout out to Will. So I'll have the 2 on the bottom. Let me just put root 3 right here. Times y. Yeah. Take out the 2 from here and you're left with 2 over. So then I have 0 is equal to 30 plus 9y over 2 plus root 3 over 2 times y. And subtract 30, subtract 30. I have negative 30 is equal to this, 9y plus root 3y over 2. These have the same denominator, so you could just add the top and the bottom, or like make it into 1. So that's what I did, and then I multiply by 2 over here, multiply by 2. Did I make a mistake? For some reason, we're going back to pencil, you guys. So I'm not comfortable with this. Originally, I just had this. I want to see where I went wrong. It's equal to the triangle derivative. Or technically, it'll be 2 now because it was 2 here. It was this, and we simplified it. Right, and then it was minus the 3/2 times 20 minus 3y. We said to set it up equal to 0. So then I did the plus minus 30y to the 0 side. So I have 3/2, 20 minus 3y is equal to √3/2 times y. And then, having simplified it, it was, oh. Okay. I added that, yeah. This is still minus. So I think I made a mistake on my original worksheet when I was solving it. So then I have 60 minus 9y/2 is equal to this. Plus 9y/2 plus 9y/2. And then 60 is equal to √3/2 plus 9. This is y here. Okay. So I don't know why I had a negative here, but we'll stick with the correct one. So this is what I have. You can see the work that I did for it. Oh, I did not subtract. I kept them all on the same side, and I'm supposed to subtract. It's 60 divided by 3 times 20 divided 3 times 2. 60. This is actually 30. So this should be 30. Okay. So this one was incorrect because when I came here and I did this plus this is still all on the same side. And then this is what I ended up with. And then I have 30 plus that plus this. And then is that it? I decided to subtract 30 here. I'm trying to solve. Anywho's, I'm just confusing myself here, so I'll stick to this. This is the correct steps for the math. And then multiply this by 2. Multiply this by 2. 60 is equal to root 3 plus 9. And then I just took out a y, distributed a y. And then divided by root 3 plus 9. Divided by root 3 plus 9. So I have y is equal to root 3 plus 9. And then we can take this, divided by 60 is y. So we go back over here to, the original problem, which was a restriction, which was 4x plus 3y is equal to 20. So then I have, plug in the 3 times 60 over root 3 plus 9 is equal to 20. 4x plus, okay. So I'm gonna put this in the calculator. You need actually to, alpha y, 3 times alpha y, root 3 plus 9. So for this value, I got 16.77. So pretty much this is telling me if I subtract like 16 minus the 20, I will get minus 20. I get 3.227. So let me do this. So then pretty much the triangle, because this was the y, the triangle will have the perimeter will be 16.772, I'm gonna say meters, and then the square to maximize the rope would be the 3.227 meters. And there you have it. Thank you.